Hello everyone, my name is Yusen Wang and my student number is 2014666494. My supervisor is Paul Spirakis. Today I'm going to talk about my final presentation. The purpose of the project is to study whether indifference, the most extensive concept in fair division, must exist in every division. By learning a relaxed version of indifference, which is namely indifference of to any good, I will discuss two players with additive valuations, two players with general valuations, and many players with identical valuations. In the above three cases, EFX distribution can be obtained under the premise of satisfying Pareto optimality. In order to make the presentation more intuitive, and the website presentation will appear when describing the results of the algorithm. For the general additive situation, both players have the same quantity and type of goods. Each product has a different value for different players. Each player has a different value for the same product. And once the product belongs to a particular player, another player cannot own the product simultaneously. Here, we introduce an example to make the concept clear. There are two players A and B in the table and three products A, B, and C. Player A's value for obtaining commodities A, B, and C is 5, 4, and 3, respectively. Player B's value for obtaining commodities A, B, and C is 6, 2, and 1, respectively. For example, if player A gets products A and B, player B gets product C, then the final value of player A is 9. It's like the value of product A is 5, the value of product B is 4, and the sum is 9. And the final value of player B is 1. The solution to players with additive valuations is to arrange and combine the products that the players have already obtained. The prerequisite is that each player is allocated at least one item. The code will calculate all permutations and combinations, and the amount of difference will between each pair for all permutations and combinations. After circularly comparing all combinations, relating the group with the smallest difference amount is the EFX solution in fair division. The code is based on the Lax-Mean solution to satisfy better the maximum distribution of the player's minimum utility so that the final fair division can get the global maximum and the second maximum. Here, we combine the website to show you the results of EFX distribution. First of all, I will show you the functions of register and login. When the user completes the registration and login process, we come to the main page. Here, we enter the number of players as 2 and the number of products as 3. Then select the Additive button. At the top of the page, it will show the number of players, the number of products, and the type of problem to be solved. Before entering the value that each player gets after acquiring the product, the user can enter the value of each product through the promotes in the input box. This function is realized through the placeholder of the input in the HTML tag. Next, we enter the value of each commodity. Then click Submit. And we can get the result. Here we find that the web page assigns product 2 and product 3 to player 1 and product 1 to player 2, and the final total value difference between the two players is 1. According to the definition of AFX and PO, we found that it's happy that the algorithm obtains the result of EFX while satisfying the PO. Next, we discuss the two players with general valuation situation. The situation for two players with general valuations is a bit complicated because a subset of each product needs to be considered, making the algorithm's design and operation more difficult. In the case of two players with general valuations, each player has the same number of products, and each product has a different value, which is the same as two players with additive valuations. The situation of two players with general valuations adds to the situation that the value of the subset after the product combination is different. The combination of the product doesn't simply add the value of each product, and sometimes it even appears that the total value of the two products at the same time is lower than getting the status of any one of them. Consider the situation of subsets will be closer to life to achieve a more comprehensive problem. Here, we introduce an example. There are two players A and B in total, and three products A, B, and C. For player A, the value of getting commodities A, B, C and getting commodities A, B, A, C, B, C, and A, B, C at the same time are 3, 4, 6, 8, 10, 8, 15, respectively. For player B, the values of getting commodities A, B, C and getting commodities A, B, A, C, B, C, and A, B, C at the same time are 5, 2, 8, 9, 15, 7, 16, respectively. The difference from the two players with additive valuation situation is that this situation needs to consider the combination of products with different prices due to the player's personal preference, which is the case of considering subsets in the general situation. The algorithm mainly considered the situation of two players and three commodities. It obtains the file division of EFX under the condition of satisfying PO through different permutations and combinations of the three commodities. By integrating the Lexmin++ solution and cut-and-choose algorithm, the player's utility is increased for sorting. Sorting based on players with the same utility is also a significant part of the algorithm. By storing the commodity prices obtained by players in different situations in a dictionary, consider the prices and combinations of the commodities themselves firstly, and then consider the subsets of various permutations and combinations into the algorithm. The algorithm is divided into three steps. First, the algorithm combines the products that each player has allocated. At this time, each player combines all the subsets of the single product that has just been allocated. Second, for the result of the previous step, two players will have two different subsets. Third, through pairwise comparison of subsets, the combination with a minor difference is finally obtained. By continuously repeating the for loop steps, all the situations are considered, and all the possibilities are traversed to arrive at the AFX solution. The algorithm returns all permutations and combinations through the new ZIGI function and lists all the combinations in a list. The CMP algorithm is used to calculate the difference between the total value of two players after obtaining the goods. Next, we enter the value into the website and find that player A will eventually get products A and B, and player B will get product C. In this case, it's also possible to obtain the EFX allocation algorithm when the PO is satisfied. Now, we discuss many players with identical valuation situation. What's the identical situation? All players have the same number of products, and each product's value is the same for all players. When the number of products is greater than the number of players, it becomes more meaningful. So we assume that the number of products is greater than the number of players. Here, we can give an example. There are 3 players A, B, C, and 4 products A, B, C, D in the table. Players A, B, and C get 5, 6, 8, 4 for the value of goods A, B, C, and D, respectively. After the user enters the number of players and the value of the products as required, the CMP function in the algorithm can calculate the value of each 2 players after allocating the product, subtract them to make the difference, and then add their absolute value, which can be used as a basis for determining the EFX solution. The algorithm subdivided the situation of many players identical into 2 cases. The number of products can be divided evenly by the number of players, and the number of products cannot be divided by the number of players. The criterion for judging is that the remainder function in the algorithm can mark the remainder to determine which situation it belongs to. In the case of the number of products can be divided evenly by the number of players, the algorithm first permutes and combines the product's ID and divides each permutation and combination according to each player's allocation of quotient products. Because it can be divisible, all commodities can be allocated successfully. Inspired by the Lex-Min solution, the following describes how the algorithm maximizes the distribution of the minimum utility of any player. The algorithm will arrange and combine all commodities on the premise that commodities can be divided. Compare and judge the difference in all permutations and combinations and get the EFX solution when the algorithm gets the smallest difference. The basis for judging the number of products cannot be divisible by the number of players. It's still based on the remainder function. First, the product ID is arranged and combined because the number of products can be divided evenly by the number of players. The result of the permutation and combination is assigned to each player's quotient products. After each player gets the quotient products, remainder products are left in the total products. Next, we need to deal with how the remainder products should be arranged and combined before assigning multiple players. The number of players is now greater than remainder. Because the number of products is not enough to be allocated to each player, the algorithm will allocate the products to the former remainder players after permutation and combination. The algorithm will calculate the sum of differences after permutation and combination, compare and record the current arrangement of the smallest sum of differences. After recording, the algorithm deletes the products that have been allocated and the players who got the products from the list, and then perform the same permutation and combination on the remaining products and players until all the products are allocated to the players to get the EFX solution. After we enter the data into the website, we get the result that the system gives us. The system assigns product A and product D to player 0, product B to player 1, and product C to player 2. This also fully satisfies the distribution of PO and EFX, so the website algorithm is relatively successful. Thanks for your watching.